If you have a function, let's call this f of x, and we have another function below that one, let's call that g of x, and if we find the area under f of x, and then subtract out the area under g of x, so we're subtracting this area out that's underneath, we get the area that is in between the two functions. So we have f of x, the area under f of x, minus g of x dx gives us the area in between those. So let's say if this entire area was 10 and the area below was 3, then we would have an area of 7 in between. If this is f of x up here and we have g of x down here, we can still do subtraction. We can take top minus bottom, and we can find the area under both curves. Let's say this was an area of 10 and this was an area of negative 3. Well, we have a total area of 13. But f of x minus g of x is going to take care of that because we would end up doing 10 minus negative 3. That'd be 10 plus 3, and we get that total area of 13. If f and g are continuous with f of x greater than or equal to g of x throughout a and b, then the area between the curves y equals f of x and y equals g of x from a to b is the integral of f minus g from a to b. So we subtract top minus bottom. Example 1, applying the definition. Find the area of the region between y equals secant squared x and y equals sine x from x equals 0 to x equals pi over 4. So secant squared is the top function, and sine of x is the bottom function. We're going to integrate from 0 to pi over 4, top minus bottom. So secant squared x minus sine of x dx. The integral of secant squared is tangent of x, and the integral of sine of x is cosine of x. And we're evaluating from 0 to pi over 4. The tangent of pi over 4 is 1. Cosine of pi over 4 is square root of 2 over 2. And then the tangent of 0 is 0, and the cosine of 0 is 1. So we have 1 minus 1, we have square root of 2 over 2. Area enclosed by intersecting curves. When a region is enclosed by intersecting curves, the intersection points give the limits of integration. Example 2, area of an enclosed region. Find the area of the region enclosed by the parabola and the line. So we have the parabola is the top function and the line is the bottom function. We got to find out where these graphs are intersecting at. So we set 2 minus x squared equal to negative x. So 2 minus x squared equal to negative x. 0 is equal to x squared minus x minus 2. We factor this, x minus 2, x plus 1, and so x equals 2, x equals negative 1. Well, now we're integrating from negative 1 to 2. The top function is the parabola. We have 2 minus x squared, and then minus the line is the bottom function, which is negative x. And then we have dx. When we integrate, we get 2x minus 1/3 x to the third. That's going to be plus x. We have plus 1/2 x squared, and we're evaluating from negative 1 to 2. So when we plug 2 in, we get 4. Minus 2 to the third is 8. We have 8/3. And then plus 4 over 2, which is 2. And then we subtract, and then we plug negative 1 in. That's going to be negative 2. And then we have a plus 1/3. And then we have plus 1/2. 4 plus 2 is 6, minus 8/3. And then we have plus 2, minus 1/3, minus 1/2. 6 plus 2 is 8. And 8 times 6 is 48. So we have 48/6 minus 16/6 minus 2/6 minus 3/6. So 48 minus 16 is 32, minus 2 is 30, minus 3 is 27/6, and that is 9/2. Example 3, find the area of the region enclosed by the graphs of y equals 2 cosine x and y equals x squared minus 1. Let's go to y equals, and let's put 2 cosine of x into y1 and x squared minus 1 into y2. Let's go zoom number 6. Here comes the cosine graph. And then we'll have the parabola. And we need to find the intersection points, and the enclosed area is right in the middle here. Second, calculate, we're going to do intersection, number 5. We'll arrow over, enter, enter, enter. And now watch this. We can quit out of here. If we type x, that value for x is stored in there. And now we can hit STO, store that into, let's say, alpha A. So we'll store that value into A. If we go back to the graph and do intersection again, intersect, and we go over the other side, enter, 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 we find out that we have symmetry here, and this is the positive value of the A we just had, or the value we just had. So we're going to quit out of here. If we go X again, we can store this into, maybe we store this into B. Well, now we're going to go to math, number 9, and we can go from A to B. And instead of typing the equations in again, we can go to variables, VARS. Let me get this on the screen. We can go variables. We can go to Y variables. Whoops, I hit graph. Let's quit out of there. Arrow over to here. There we go. Variables, Y variables, function, enter. And the top one was the cosine. That's the first one I entered in. And then we're going to minus, go to variables, Y variables, and we're minusing Y2. And it's with respect to X. And we get 4.995. 4.995. Example 4, finding area using subregions. Find the area of the region R in the first quadrant that is bounded above by y equals square root of x and below by the x-axis and the line y equals x minus 2. So there is the square root of x. Here's the line. And then we're also bound by the x-axis. Well, if we're going to do top minus bottom, then we're going to integrate from 0 to 2 of the square root of x. Because the area under the curve goes to the x-axis, so we're good here. Well, then we're going to add that to, we need dx here, the integral from 2 to 4, so 2 to 4, of top minus bottom, which is square root of x, and then minus the line, which is x minus 2 dx. Well, this is x to the 1/2, so if we add 1, we get x to the 3/2, and then times 2/3. And we're evaluating that from 0 to 2, and then plus, we have the same thing again, which is 2/3, x to the 3/2, and then minus 1/2 x squared, and then plus 2x. We're evaluating that from 0 to, not 0, but 2 rather, 2 to 4. When we plug 2 in, we get 2/3 times 2 to the 3/2, but when we plug 0 in, we get 0. And then we have plus 2/3 times 4 to the 3/2 minus, we'll put this in parentheses, 16 divided by 2 is 8, and then plus 8. Then minus, we're going to plug 2 in, so 2/3 times 2 to the 3/2 minus 4/2, which is 2, and then plus 4. Well, notice we have 2/3 2 to the 3/2 plus a negative 2/3 2 to the 3/2. So these actually cancel out. The square root of 4 is 2. 2 to the 3rd is 8. We have 16/3. These cancel, make 0. And then 16/3 plus 2, which is, but it's actually minus. So instead of plus 2, this is going to be minus 2. We have 16/3 minus 6/3, which is 10/3. Integrating with respect to y. Find the area of the region in example 4 by integrating with respect to y. So here's example 4 again. If we're going to integrate with respect to y, we need to solve this equation for y. So we have y squared is equal to x. Then we have to solve this one for y also, so we just have to add the 2 over. We have y plus 2 equals x. Well, now we see that the line right here is to the right side of the curve the entire time, but from 0 to 2. If we're integrating with respect to x, we integrate from 0 to 4, and we have to do this in pieces. But if we're going to integrate with respect to y, we're integrating from 0 to 2, and instead of doing top minus bottom, we can do the right curve minus the left curve, because This curve is to the left of the line the entire time. So now we're going to integrate from 0 to 2 of right curve minus left curve instead of top minus bottom. So the right curve is the line, y plus 2, minus the left curve is now y squared dy. Now before we got an answer of 10/3, so this better end up being 10/3 because it's the same area. We have 1/2 y squared plus 2y minus 1/3 y to the third, and we're integrating from 0 to 2. Now that's equal to 4/2. When you plug the 2 in, that's 2, plus 4, and then minus 8/3. But then when we plug in the 0, that's all zeros. We have 6 minus 8/3, which is 18/3 minus 8/3, and we get the same answer, 10/3. In example 6, we get to make the choice whether we want to integrate with respect to y or we want to integrate with respect to x. So let's graph it and then we'll make our decision. So let's turn the calculator on. We'll clear what we did before. Let's go to y equals. I'll clear these out. Clear that out. And let's get these to say y equals. That one's already good. But this one is x plus 2 equals y squared. So y equals plus or minus the square root of x plus 2. So let's do x to the third. So we have x to the third. This one is going to be the square root of x plus 2. And we need the negative square root of x plus 2. And let's zoom 6 it. Let's graph. Find the area of the region enclosed by the graphs of y equals x to the third and x equals y squared minus 2. So we have a choice here. Do we want to integrate top minus bottom or right minus left? Let's plug these into the calculator, and if we're going to do that, we have to get y equals. We have x plus 2 equals y squared, so y equals plus or minus the square root of x plus 2. So let's put x to the third in y1. X to the third. And then we have the square root of x plus 2 in the first, in y2. And then negative square root of x plus 2 in y3. Let's graph it. There's the x to the third. There's the top half of the parabola, and then here comes the bottom half of the parabola. We have to decide, would it be better to do top minus bottom or right minus left? And in this case, we see that the x to the third is to the right of the parabola the entire time. So now we need these two intersection points, and we're going to take right minus left rather than top minus bottom. And even top minus bottom would be a problem because you'd have the top minus the bottom, and it's kind of the same equation. Just one's a plus, one's a minus, and that's not going to work real well. So right minus left is definitely the way to go on this one. So let's do calculate. We want the intersection, and we're going to arrow over to this intersection. We want the x to the third. We don't want that top one. We want the bottom half of the parabola. So we press enter, arrow down to it, press enter, and then we find out that we're integrating from -1. So now we're doing y. We're integrating. We need this to be the third root of y equals x. So that's going to be the right function, third root of y, and then minus y squared minus 2. And we're using y values, so -1, 2. We need this y value up here, again, because we're integrating with respect to y. So let's go calculate intersection, and we can arrow over, enter, and then one more time, and we find out the y value is 1.793037. So let's quit out of here. Let's get y up on the screen here, and we're going to go, I got to find y. So alpha y, and there's the value that was stored in there, and let's store that into, we could use y, but how about we store that into b? So we're integrating from -1 to b of this function right here. Let's go into math number 9. We're going from -1 to b, and we need third root of y. And x is on the keyboard, so instead of using y's on the calculator, let's use x's. And that's third root of y is to the 1/3 power. It's the same thing. And then minus y squared, or in this case x squared. And then we have plus 2. Whoops. plus 2, and we're integrating with respect to y, but on the calculator it's x. And we get a value of 4.215.